Greetings, sir. With us, we have our speaker, Dr. Jagannath Raju, an avid marathoner, an IIT-M, UCB, and MIT alumnus. In addition to this, he's also the co-founder and CTO of Systemantics India Private Limited, one of the pioneers of making robots in India. We, IEEE RASPESU, are honored to have you here, sir. Sir will now be guiding us on how to build on the lapses of the current education system and stand out. We have our audience watching the talk on YouTube, sir, so we request you to please begin.
Thank you. Good evening, everyone. So how many people do we have approximately listening in?
Right now, yes, sir. So on the YouTube stream, right now we have around 8 people.
So do you want to wait for 2-3 minutes for people to join in, or you want to get started?
You can get started, sir.
Okay, so give me a minute. I want to just close. Just hold on 1 second, okay?
Yep.
Okay. Okay, thank you for that short introduction. So one of the things that I keep consistently being asked to do is to give a talk on robotics. They say what's happening in robotics, etc. And most of the time, I decline to give the talk for various reasons. One of the reasons is that I think this generation is so clued in to digital media that you probably know more about this than I do, right? A lot of the videos and are much more up to date. The other question I keep getting asked is, why is it that in India, we don't have any robotics related products, right? We don't have any industrial robotic arms that are made in India. And now with the focus shifting to the service sector, you keep seeing videos of humanoids, you keep seeing videos of quadrupeds. I think all of you would be very familiar with companies like Boston Dynamics, iRobot, Universal Robots. There are a whole bunch of them. But the key question is, why is it that in India we have not been able to develop any product that would be able to compete in the global markets? So I'm not going to give you, it's a very complex scenario, it's very complex, there's nothing very simple about an answer. So what I am going to do is, I am going to talk about 3 or 4 things that go into building an ecosystem that allows people to, that promotes the kind of mindset, the kind of culture, the kind of environment that spawns the kind of technology entrepreneurship that is the root of such product development. And let me set the background first. And this is a disclaimer. This is what typically people put in fine print, but I'm giving you a disclaimer. This is based purely on personal experience, right? I've learned a lot from my mistakes. So it's based on personal experience, and it is not something that you should take as gospel. It is something that you must think about and say, is there a balance somewhere? Is there something that we can do differently to be able to be part of a global ecosystem, especially in the robotic space, because it is now one of the very fast growing growth markets. Everybody is looking for robotics post-COVID, especially in the service sector. A lot of people are looking for robotic solutions. And my experience is based on studying in India at what is considered to be a premier institute, and comparing that with what I did in the US, which is, again, I studied in 2 universities, which are, again, considered to be premium institutes like UC Berkeley and MIT. And in addition to that, I have experience having spent some time in Japan as a visiting scientist to the Japanese national labs. And as many of you would be aware, Japan is a very big player in the robotics segment. So I will draw upon my experience in the US, in Japan, and a large part of my adult life after having come back to India. Now I've spent more than 25 years back in India. And I did notice that this is IEEE Robotics and Automation Society event. I just graduated to becoming a life member of IEEE and the Robotics Society just last week. I went for, which basically means I don't have to pay dues anymore for the rest of my life because I've been a member for 25 plus years. So I'll bring that to focus. As I mentioned, a lot of the, I also have experience in having worked with the government as a consultant and having built a lot of systems for the Indian government. Been involved with the DRDO lab, I've been involved with the National Institute of Ocean Technology for underwater robotics, quite a bit with the nuclear industry and building systems for nuclear applications, basically fuel handling applications. So bringing all of that together, I finished my graduate school, spent a bit of time in Japan as a postdoctoral scientist, came back to India, worked at a government, actually as a consultant to the Center for AI and Robotics, which is based in Bengaluru, and ended up starting a company here, primarily because I couldn't find a job at any place which was doing research and development, so I ended up starting this company. Now, what I'm going to do is I'm going to sort of compare the ecosystem in India, in the US, and Japan, and talk about the ecosystem, the culture, and the mindsets that we have, and what is different, and what is it that can be different. One of the things that has changed dramatically for my time is, in my time, the only options, and this is what parents would look to, is either you become an engineer or a doctor, or given that if you don't do either of those, maybe a lawyer or somebody else, but there were really no career options. So one cannot judge parents who say, tell their children to go do engineering because that's, or medicine, because that is the only path to having employment in India. What one must realize is that has changed dramatically in the last so many years. But the mindset that one should stick to engineering and medicine appears not to have changed. So you still see a lot of people doing engineering, primarily because their parents said do engineering. In my time, we didn't have much information, so basically we listened to parents, but now I'm sure all of you have much better information on what's going on in the world. And I can guarantee to you that whatever you excel in, irrespective of whether engineering or anything else, there are job opportunities in the new digital world. So if you are doing engineering, you should be at the point of saying there are a lot more opportunities and I can do a lot of things that I am interested in rather than catering to somebody else's thoughts about what you should do. you can be sure that in India we have the same distribution of intelligence, may not be more, may not be less than elsewhere in the world. And you will also see that people who graduate from Indian schools go to the US and end up doing very well there. There are lots of stories of those. So, what is it that changes the minute you go abroad and you are part of a different education system? What is the primary difference? And what is it that makes you realize your potential as you when you get the opportunity to study abroad? The first thing that we are very risk averse in India, right? Our style of education, the legacy style of education is if you score 85 and somebody else scores 84, you're better than the other person. And our idea of what is a syllabus and what you want to study is really limited to what will come in the exam. So the syllabus is defined by what will be the scope of the exam. And very rarely is it anything more than that. Some things are changing. At least in my time, all exams were closed book. So the focus was on rote learning. If you did not have a good memory, then you would do badly. So it really did not measure your understanding of a discipline or a subject or anything else. The first thing that happens when we go abroad is, in all my years at Berkeley and MIT, I can't recall a single closed book exam. There may have been one or two. But even in a closed book exam, what the professor will tell you is, you can bring all the books you want, but it's not going to help you. That's why I tell you, that don't bother with the books. If you need any help during the exam, I'm around, you just ask me and I'll help you make progress on this. Because the primary focus is, have you learned to use the material that you have been taught in class? It is not a way of figuring out whether you are better than somebody else in the class. That is not the objective that any of the top schools have in exams, right? It's very, very different. What happens is that, being risk averse, you tend not to take, and this is what I was accused of even at Berkeley by a couple of professors. They said, you're scoring very well in exams, but it's probably because you're not taking any challenging subjects. So they're very happy if you take a course and you don't do well at it. And their way of looking at it is, you took a very challenging course and you didn't do well, but you learned something. Maybe you didn't get a very good grade. And we are averse to that. The minute we go there, we want to keep good grades and everything else. Every course in one of those premier institutes in the US has a project associated with it. And how you do in the project is something that really gives you a very hands-on experience of the material you have learned. What we had at IIT was, you had a theory class, and maybe 2 months later you had something in a lab where you wrote up some report of some of the theory, and there was really no correlation beyond that. So that's one of the things that makes a lot of people who go through that educational system have the confidence that they can actually build something from the material they've learned. That gives you that confidence. Even as far back as I was at Berkeley in the late 70s, very early 80s, and I was in mechanical engineering. And the first course that I was asked to take in mechanical engineering by mechanical engineering faculty was a course in digital logic systems. And I had never seen an integrated circuit in my life before. And we were made to build electronic circuits using integrated chips, integrated circuits, because there was a recognition there that engineering will no longer remain this legacy categorization of mechanical, electronics, electrical, whatever you want to think about. They were very clear that engineering will be very multidisciplinary. You have to understand basic physics and mathematics. And if you are good at those, you can pretty much practice anything you want in terms of engineering career. So you'll find that most of the top schools in the US have graduated not worrying about which department you are in. That's purely administrative thing. Your coursework will be decided by what you want to do after you graduate. Do you want to be in manufacturing? Do you want to be in healthcare? Do you want to be in automation? Whatever it is, they give you that option. And I am considered to be a robotics person now, but I've never, in the entire coursework, never had a course in robotics. It never even existed at that time. But what was my coursework? My course was in mathematics, in dynamics, in physiology of humans, which allows you to figure out how the vision systems work, how all these things work. So they were very, very clear. You learn fundamentals, be interdisciplinary, and you will be able to accomplish whatever you want. And the opportunities will come. You should not be taking courses because somebody tells you to take those courses. There are, of course, again, you have a balance. There are some core courses, but even during my time, the emphasis was, and I can tell you all my peers at MIT who did very, very well, all had undergraduate degrees in either physics or mathematics. And then they did engineering as a graduate course and did very, very well. In India, very few people now take up science as a stream because we have kept our legacy system that if you do a bachelor's in physics, you won't get admitted to a master's in engineering at any school. So we have created this artificial boundary that once you have made a certain selection, you will not have an escape route from that to pursue a different career. And I'll tell you how dramatic that is, because when I was at MIT, one of my senior professors, he decided at that age that he wanted to give up engineering. He was a person in thermal sciences, and he wanted to study architecture. And nobody blinked an eyelid. Nobody blinked an eyelid and said, "You're making this decision later on?" Because it's all about learning at the end of the day. So when people say you have to make a decision now, whether you want to be in computer science or you want to be in mechanical engineering, electronics engineering, it will not make a difference to you later on in life if you focus on learning. In fact, all the top schools in the US, when you get admission, you don't have to tell them what you want to do in the first year. In any case, you will take all core subjects. You only have to declare at the end of the first year what engineering you want to do or what you want to pursue. Because you should not be knowing what you want to do. If there is something wrong with you, if you know coming out of high school that you want to become a mechanical engineer or a chemical engineer, I mean, somebody has told you that. You don't have enough information. What you do gather in the first year of college, you'll get more exposure. There will be departments where you can get more information and make up your mind what you enjoy doing, which of those. Whereas, we have built up a different caste system in India now, that even in the joint entrance exam for IITs, if you are not in the top 200 ranks, you won't get computer science. If you're not in the top 800 ranks, you won't get something. And there are so many opportunities in all forms of engineering, in metallurgical engineering, all the integrated circuits. The people who are designing the latest, fastest integrated circuits all have backgrounds in metallurgy, physics, and subjects like that. They're not electronics engineers who design those. The electronics engineers use those designs to build other circuits. So don't be fooled that any decision you make today, because you have chosen a certain stream, is going to be something that you have to live with for the rest of your life. Things are changing. You can make decisions later. As long as you focus on the fundamentals and you are strong in the basics in mathematics and physics and all those, you can always make changes. I'll come a bit, as I said, we're all risk averse in India. But is that the only, and we have an education system that is very conformal. You have to be part of that education system. You have to score well in exams. You're considered to be very good if you do that. All that is exactly the same in Japan. They also have a very rote learning system. The kids there are under tremendous pressure. After school, they go for tuition in the evenings. Everybody wants to join Todai, which is the University of Tokyo, is the top school. If they don't get in, they get depressed. Exactly the problems. Exactly the same kind of system that we have in India. But they excelled at, and especially since I'm in the robotics, Japan dominated the robotics market in industrial robots for a very long time. So what was it that was in Japan when we share the same kind of education system, but people were able to get around it? I was going to start this talk by giving you the quote, the very famous quote from Mark Twain, which was that he never let college interfere with his education, which is very true in India and it's also pretty true in Japan also. But the big difference, and this is something that is common to both US and Japan, is a lot of the jobs that kids do while they're growing up are very customer-centric. So a high school kid in the US doesn't try to do an internship at Apple. The high school kid will go and do an internship at McDonald's. Actually, it's not an internship, it's a part-time job. Similarly, in Japan, there'll be lots of kids working in supermarkets, etc., etc. Why does that make so much of a difference? It makes a big difference because every single one of those jobs is customer-centric, where you get to deal with customers. Customers are king, and you understand what are the problems that customers have and how you can deal with customers. That is what translates into what is now a very big hype of design thinking. Design thinking is something, all that it says is know what the customer wants before you start a design. That's the real essence of design thinking. And unless you are exposed to an environment where you are not looking at customers, you will never be in a position to understand what is it that you want to work on, how is something that you're going to work on become useful. If you notice, all our top institutes in India, engineering institutes, you take the IITs, you take the NITs, and you take the ones in the cities like PES, RV, and the other well-known colleges, Gindi, etc. We all go to college completely surrounded only by engineering peers. But look at the universities in the US, whether you're at Berkeley or MIT, you are surrounded by people who are not engineering, who are not engineers. And there is so much to be learned by that. I'm going to give you a few examples of each of these things to bring you back to say why this is so important. Let me start with the first one, which is being risk averse. So I took a course in the US in heat transfer. And as I said, we had to do a project. And most of us in the class, graduate students, were all Asian or foreign. There were a few American students. And we had to select a project to do. So I selected some very analytical project. I said, I'll figure out how a two-cylinder engine, how I'm going to dissipate the heat, design the fins so that the heat dissipates very fast, and and I'll do the design. Very nice. You can write nice equations for it. But the professor, who was one of the top professors in transfer, was not very thrilled with my project. I mean, he said, great, maybe you'll come out with some nice graphs, it'll look very colorful, you'll have some results. One of the American kids, he said, I will figure out how to get a pizza home without it getting cold. I've asked a bunch of people, why was the professor so happy when that proposal was to do that as a project? And I've gotten replies who will say, well, it's a real world problem, etc., etc., etc. The real reason why the professor was very thrilled with that is because it's such an unstructured problem that you will have to think through it very, very clearly before you can come up with some kind of a solution. For example, you will need to know what is the thermal capacity of cheese. There's no book that you can go to and look for the thermal capacity of mozzarella cheese or something. You will not find it anywhere. If you can't find it, then you really have to understand what is thermal capacity. You'll have to do an experiment maybe with cheese and figure out how long does the heat stay in that and what are the thermal coefficients, etc., etc. You have to make so many assumptions. You could be wrong. But the learning that comes from unstructured problems, where you have to make assumptions and you have to live with the consequence of the assumptions you have made, is something that we are never, never, never exposed to in our educational environment. We are very good when there is only a single answer to the problem that has been given in the exam, and we will get to it. And this is something that a lot of US professors have told me. You guys do very well in exams because if I give you a problem and there's only one answer, you guys will get to it very fast. But if I ask you to make an assumption, you'll be lost. You'll come back and say, you didn't give me this input because of which I cannot do this problem, so you're wrong, your question is bad. Something like that will happen. In Japan too, people are very risk averse. And one of the things with their society is that there is a sense that if you fail, you have to pay for it. Sadly enough, a lot of people commit suicide. The concept of harakiri is there. There is also the concept in Japan that there is a saying, if there is a nail in the wall, you please hammer it in, which means don't be non-conformal, be conformist, which is very similar as we are in India. If you go out with a mode of dress or you do something which is unusual, people will tell you, no, don't do that. This is what you're expected to do. But they're still very successful. And I'll give you an example, again, why they're successful. One I've told you is they're very customer-centric, and I'll give you an example of how customer-centric they are. So I was in a railway station in Kyoto, one of their big cities. I had just taken the train, arrived at the platform, and I told some of my guests, I will find my way to your place. You don't have to come and pick me up at the station. I went into the bookshop. You can always get maps. You can get everything there. I picked up a map and a booklet, took it to the counter, and in Japan, whenever you buy anything like that, they cover it with brown paper and give it to you. So this young lady, obviously somebody either high school or just getting into college and working to make some money, she pulled out a brown sheet of paper, started folding it around the thing. How you cover, I don't think we do it anymore. We used to cover all our books with brown paper at one time. She made all the creases. She got the last crease slightly wrong. What do you think she did? She opened it, put that thing aside, started fresh with a new sheet, and got everything exactly correct, perfectly correct. Two parts of it. One is that attention to detail, which is part of the Japanese culture, is what made them so successful, because the creativity was still in the US. They looked at US designs, everything, but built them better than what the US manufacturers could do. You know what happened with the auto industry. Japanese cars started off very poorly. They learned everything about quality control from an American who was shunned in the US and went to Japan and is the biggest name in Japan in the automotive industry, right? All the quality control awards are named after Deming, and Deming was a US person who was shunned by Detroit but accepted in Japan. So that attention to detail and the customer and being customer centric, that you have to do stuff which the customer is looking for, is really something that the Japanese possess, and that is what has made them very, very successful. They still have the same system as us. There are exams, and people who do well in exams get to the top schools. It's very different in the US. They have SAT scores, they have all those things, but when you get admitted, the university looks very closely. They talk to your high school counselors, they do all of that before figuring out whether they're going to give you admission. They look at interest, they look for evidence on various things, so it's a very holistic system. Unfortunately, in India, for engineering, the joint entrance exam is, the way I call it, is the beginning and end of engineering education in India. Because by the time you're done with that, I think you've lost a lot of your youth. You haven't enjoyed what you have been doing, and you are spent. That's what it looks like. What the educational system has to do is not, the end result is not that you will find a job. The end result has to be that you will hold on to a job and grow in the job. We look at it as saying, okay, this is the means to get a job. But I can assure you, if you don't have your fundamentals and you have not practiced in terms of, using whatever you have learned analytically, you will not be able to hold on to any job. Look at all the entrepreneurs in the US. Imagine what would have happened in India if Bill Gates had come home and told his parents, I am at Harvard and I'm in my third year, but I'm going to, drop out so that I can start a company. You know what would have happened here, where the parents would have gone ballistic. And the same thing is true, whether it's Mark Zuckerberg, Bill Gates, the person who designed the Apple computer, that was Steve Wozniak. Steve Jobs was the salesperson. All these people had no hesitation in dropping out of college because they knew what they were doing in terms of their passion was there, and they did not have to worry about holding on to a job anymore. This is not to suggest to you that you should drop out of college. I'm not suggesting you should drop out of college. But look at college as just another step to achieving the next thing, which is having a very interesting career, doing things that you enjoy. And you will always find something, and that's the thing that has changed. Slowly we'll find that nobody is going to go back and look at whether you graduated from a certain college with certain marks once you've established that you know what you're doing. So there are a lot of these things in terms of the ecosystem and the culture that sort of is taking a lot of time in India. I do a lot of work still with the IITs. Since I'm an IIT Madras graduate, I am on some committees that advise them on coursework and all. And I still find it a struggle to convince people that, you should not focus so much on the way you structure exams. Every exam should be open book. It's a big burden on faculty, which is one of the reasons why I think we still retain a lot of the legacy kind of systems that we have. The other thing that I've found is we still have a very much of a guru-shishya kind of structure in the student-teacher relationship. It's still a student-teacher relationship. It's very different in the US. I learned linear algebra from a professor who is famous worldwide, Gilbert Strang. And in any of these courses, I really never had to do homework. You could just sit and listen to his course and learn the subject. But Professor Strang never behaved with students as if he was the teacher and you were a student. He would almost treat you as an equal in terms of learning from you, because he's a mathematician and I was studying robotics. And he would sometimes show up at my desk as a graduate student and say, show me how you are using, these homogeneous matrices and what exactly are you doing with them in robotics? Because he wanted to, and robotics was really just starting off at that point. He wanted to get an idea of how useful the advanced mathematics course I had taken with him, which was, a lot of it was linear algebra, was being used in the work that I was doing. And these are the kind of things that you slowly realize much later on is the reason you, speaking for myself, you continue to have the same passion that you had when you were a student. I still continue to have the same kind of passion because of people like Gilbert Strang, knowing that I think he must have retired by now, but he had nothing to gain in terms of, coming and sitting with me, but he was so passionate about it. There are very few role models like that I had in IIT or anywhere else, which, would have made so much of a difference in this kind of a system. One of the things that you will find in the US is that I hope people understand the difference between invention and innovation. Invention is something that happens, with a lot of very expensive equipment in CERN, and where you figure out, positrons, and that's all invention and very basic sciences. Innovation is something which is different. It's like tweaking something to do it better or coming up with a fresh idea on how to realize something, and it's really not invention per se. Innovation is the driving vehicle of a lot of industries. And innovation happens really in small businesses in the US. That is something that is heavily promoted by universities, where faculty get very involved in promoting small businesses, where they can mentor people, etc. The government is very involved in funding small businesses which are doing innovation. They give grants. A system like that is completely missing in India. Now you can say there's a startup culture, but the startup culture is very different from an innovation culture. A startup culture is trying to promote, telling you, you can do something, have an idea, and then you can grow a business. Innovation is different in the sense that you are trying to do something which will be competitive, globally competitive in terms of improving a process or doing something in technology which is different, which is competitive. So a lot of these things keep us from being able to grow companies that can compete in the global markets. And having tried to do that for the past 20, 25 years, it must be a challenge. Despite all the experience that I have and the opportunities that I've had, very fortunate to have a lot of those opportunities, it still is a system where there is no ecosystem that really supports this kind of innovation. So I don't want to spend too much time going through a lot of other stuff, because there are, as I said, it's a very complex thing, and one cannot be judgmental in saying that this is going to be, there are solutions, somebody is wrong, somebody is right. It's more that when you do get an opportunity to take the less traveled path. It's a very famous poem, which actually is the most popular poem in the thing, which is to take the less traveled path. You should not hesitate to take it. You should never hesitate to take it. It is something that has very, very good rewards at the end. It will be a more difficult path, but the rewards that you will get at the end more than justify anything that you have to do to get there. I want to, Aditya, I want to spend more time actually taking questions rather than having this as a pure monologue. So would you prefer that we actually field questions more than, and then I can give more sort of customized feedback to people?
Yes, Ravi, there are a couple of questions in the chat. Most of it you've kind of already answered, but then I'll still read it out. So the first question is, why do US institutes, what do US institutes look in a student while offering admission?
Okay, that's a very interesting question because I've written a lot of recommendation letters. If the US Institute sees a recommendation letter, and let me back up a bit again. I do know how faculty look at recommendation letters because at MIT, they used to get a lot of applications from, I should say, lesser known colleges to the US faculty. They were not very familiar with PSG Tech in Coimbatore. So there was an application from a kid at PSG Tech. MIT, by the way, looks at every application that comes. There is no filter that says you are an IIT, so we'll look at you. You are from a PSG, so we won't look at you. They will look at every single application. That's one of the things that distinguishes a lot of US colleges. They don't put filters based on somebody else's judgment about college ranks and all of that. They get ranked very well, by the way, but most of the faculty, they don't believe in most of those ranks. So they look at the thing and then they try to figure out. The main thing they figure out is, will the student benefit from coming to our university? Is there something that we'll learn from coming to our college? And is there something that we will learn from this student coming to our college? What is it that you think a US university can learn from a student coming to that college? And I'll give you an example. One was, the mission of that college is not, they know that somebody who is very, very good knows everything. There's nothing that they can actually teach the person. They want to know how much difference they can make to a person, to take the person who is very raw and convert them to a superstar. That's what they look for. Now, what do they mean by very raw? There were kids at MIT who had come off the boat from Vietnam, had just landed up with a foster family in Texas, had really very little high school education. But when he applied to MIT, he had read half the books in the library. And MIT said, if this person has this kind of a mental, this thing to come off a boat and say, I'm going to succeed, we will do everything we can to make sure the person succeeds. And they gave him admission. His SAT scores may have been terrible, etc., but they said, we can contribute to this person's education. If they get a recommendation letter, and this is the example I'm giving you, there was a student who applied from PSG, and the recommendation letter for the student was from the vice chancellor of the university. They took it and threw it in the trash. Threw it in the trash bin. Why? What are they looking for? They want to know, do you really know the person? And can you tell us something about this person? We don't want to know if he's very, very good or anything. We want to know, does he have the kind of qualities that we were looking for, which is perseverance and discipline, maybe, a bit haywire because we want to look at people who want to think differently. They look for all kinds of things like that. They take no pride in admitting a gold medalist from an IIT, saying we are taking him because he's a gold medalist. By the way, I was not the topper in my class. I was closer, maybe, not to the middle, but reasonably higher. I got admission to Berkeley, Stanford, and MIT, all three of them. And later on, much later on, I asked one of my professors. I was not the topper who applied. There were various people from IITs who had applied who were gold medalists, but they took me. They said, we looked at your recommendation letters, which said basically that you're willing to try anything and you're not worried about whether it will, it will work. You're willing to try it and you will use basic physics and math to do it. So we knew you were going to try to do something differently. And I discovered that when I was at MIT that I was trying to do things differently. So if you are be assured that they're not going to go only by marks. When they look at the standardized GRE exams, they now tend to not really put too much weightage to them. So there is no formula that they have. They have enough experience after all these years to be able to judge from the recommendation letters for the most part. And maybe sort of from the way you have done your scores in various subjects, they can figure out whether you are a person who will benefit from going there. And what do they benefit? They figure out what is it that they have to change in their system to be able to teach you better. So we had a kid from a small college in New York who came from a South American country. He was very poor in analytical work. He didn't pass the doctoral exams. We were wondering how MIT admitted him. And then we came to know that they took it as a challenge, saying this kid has really tried very hard. If he is not able to pass the doctoral exam, they were actually questioning whether they had done a good job of teaching that person. They actually questioned themselves. Us as peers were trying to say, oh, he was not very good, but that's not the way they looked at it. They looked at it and said, how can we improve our teaching so that somebody who comes from a less advantaged background, who probably didn't go to undergraduate at Harvard or IIT or somewhere, we have to get those kids who will become very good engineers. And the right measure that they will use in how well they have done is to see how many of their graduates contribute to engineering as part of their career is the metric that they will use to judge how they have done. So there is no general answer. What is it that they look for? As I said, they look for people who stand out. They look for nails that stick out of the wall. And this is the top institutes. They look for nails that stick out of the wall.
Right, Jackie. The second question we have is why the legacy system is still present in the top institutions of India, though they have faculty who themselves are graduate from top US schools.
I knew you guys would come up with some tough questions and can get me into a bit of trouble also on this because it's on YouTube, no? And so there are 2-3 things that you have to look at in our academic system, right? So what happened, and this actually happened when I was at MIT. MIT has, there are 2 things about the MIT thing. You come in, you're admitted. You don't have to declare what your major is, number 1. You have to declare what your major is at the end of the first year. Within that time, you get an opportunity to work with graduate students, look at different in different departments. You learn a bit more about mechanical engineering, see what electrical engineering is all about, etc., etc. And at the end of the second year, if you think you have made a mistake, you can change again. So there is nothing that tells you that. Now, what happens? So every year MIT takes 1,000 kids. What happens if 600 of them decide they want electrical engineering? And only 10 decide they want civil engineering, okay? It happened in my time. Only 10 kids said they wanted to do civil engineering. Now, what happens in US universities is faculty's salaries, only half the salary comes from a course you're teaching. If you're not teaching a course, you get zero salary. All your salary has to come from your own research work. So faculty will teach one course for half the salary, and the other half of the salary comes from doing research work. If there are only 10 students in your department, you're definitely not going to get half your salary, right? How many courses can you offer 10 students? So civil engineering department, I don't know whether they called an emergency meeting, crisis, whatever they did. They restructured themselves in 2-3 years. Said, we are doing something wrong. Kids are coming in, they are here for a year. They have done these undergraduate research opportunity things in our department, and none of them has selected us. We have to change it. So what did they start? They started thinking about smart buildings. And this is way back, by the way. Now everybody says smart buildings can be done. They said we have to talk about smart buildings. We have to talk about how to build the lightest bridges by making all kinds of stuff. And sure enough, 3-4 years down the road, typically they get 40 or 50 undergraduates. They got their 40, 50 undergraduates. Simple as that. And of course, US universities have tenure. Now you look at, and I know IITs well enough. There's no tenure process. Maybe it's unfair to have a tenure process in India yet, because it's difficult. You can't expect our faculty to go and earn half their salary from research and stuff like that. But there is no pressure on any department that they have to cater. In fact, when I talked to faculty at IIT, there was so much, the morale was so poor in metallurgy and other departments, saying, look, the students have come, they've joined, they're not really interested in metallurgy. They haven't not taken metallurgy because they want to do metallurgy. They're all sitting and practicing aptitude tests for the IT companies when they graduate. So why should we even be teaching them? The morale was very, very, very low. So the structure is very different. So even if they have come back, at the end of the day, they're still government institutes. So what has to change is private institutes, which are not dictated to by the government, have to have the courage to make those changes. There's a new university called Plaksha, which has come up in Chandigarh with a new vice chancellor. They are going to try to do things like that. But it is very difficult for that to happen at IIT. So we'll retain legacy. There are some changes. IIT Madras has a new engineering design department, which is almost 10 years old now. Came out of mechanical engineering, but they practice engineering, very multidisciplinary, but not yet as multidisciplinary as one would like. Courses at MIT are taught by 2-3 professors at the same time, bringing different perspectives, bringing different disciplines into the same course. That's another thing that we have to get going in India to make it multidisciplinary. And the elephant in the room is going to be parents, you know that, right? No parent will say, I want my kid to join a college without knowing what he's going to graduate in. right? If you made IITs also follow the MIT model and say you came in as an undeclared major, and at the end of the first year, we'll let you choose what you want, every single student will say, I want computer science. Not because they know what computer science is, it's just because that is the prevailing caste system. That's what I like to call it. So the legacy will stay, but the change will come slowly. It will happen. Recently, some of my friends' kids got into IITs, and I get a call saying, what do you advise? And I was so happy. The two kids, one of them has taken maths at IIT Bombay, and the other kid has taken energy systems or something like that also at IIT Bombay. They stayed away from all the basic engineering, all the what I will call, legacy kind of stuff, saying we are interested in what we're going to do later. The math kid very clearly wants to keep his options open, because if he does go to a US university, he can join any department that he wants in the US. He can apply to mechanical, electronics, etc. Again, he doesn't have to worry whether he's applying to mechanical, because he is applying to mechanical because there is a professor there who is doing some work in which he's interested, and not because it's a mechanical engineering department. So all those options remain open. So legacy will stay. I'm sure PES also has its legacy systems. It's easy enough to say, let us change, and I know, but it's very difficult. We don't have the critical mass for it. We still don't have enough opportunities for our faculty to get hands-on experience and be able to mentor students to the extent that happens abroad. So I think the legacy systems will still take a while in India to be dropped.
Right. Moving on, Jackie.
Okay.
We have a question. How can a student entering into undergrad know where his or her passion lies?
Cannot know. That's the point I'm making. And you are completely normal if you don't know. And if you don't know, I would say you are very smart. Right? People who say they know are just, as I said, are saying they know because some uncle told them, somebody told them, future is in artificial intelligence, so you go to artificial intelligence. I'm looking at the third rebirth of AI right now, right? The first, I've been through all the phases so far. It's okay not to know. And by the way, I didn't tell you, I actually joined I started doing medicine, and then after a year, I really got bored. I didn't even finish a year. I realized medicine was not for me because the subjects being taught, I just had to mug up everything. And I'm very lazy by nature, in terms of lazy, not doing hard, but lazy in terms of mugging. Right? I will not do it. I will learn a fundamental, and I'm very happy I can work out what I need to do. So I knew by doing it, but I lost a year by doing that. But I know I did the right thing after that to move into engineering. Even though my father asked me to do engineering, and I said, no, I want to do medicine. Maybe because my father said, do engineering. But whatever it was, the point I'm making is it's never too late to learn something new. Learning is a lifelong career, basically. Think of it that way. I still learn things these days. So you should not hesitate to say you don't know what you want to do. Try it. You will learn something from trying it, which will be more valuable than not doing it. Much more valuable. So if you get bored for it, if you know that you made a wrong decision, there's nothing wrong with it. Nothing wrong with it. Try something else. And you will find something that by nature fits you, by disposition fits you, just the way you think. Intelligence has nothing to do with solving differential equations or being able to do those kind of things. That there's emotional intelligence, which is as important. There's so many other things. The thing that is lacking in India, which is there in the US, and that is all high schools in the US have counselors who are professionals. And they are the people who are professional to be able to advise students on how to look for what you're doing. Are you doing it because you're trying to impress somebody? Are you doing it because you really like it? Are you doing it because you like where you're working? All those kind of things are handled by professionals. Here, if you go to see a counselor, people think you're going to see a counselor because you're mentally unstable, right? That's the system we have in India. So it's perfectly normal. If you don't know what you do, more power to you. Try something, try again. It's perseverance at the end that counts.
Definitely. Yeah. Last question. If marks are not considered important, then how do US schools or colleges assess the progress of students?
Address the progress of students?
Assess the progress of students.
Now, you're falling into the trap of thinking marks are the ones that are the metric for judging progress. They are not. That's the basic fundamental thing we miss. I'll give you two examples again. And I will give you exactly the same thing. I mentioned to you, I took a course with Gilbert Strang, right? It was an advanced course. It was not the basics course in linear algebra. There were only 10 students in class. The way his teaching thing was to make you teach something, and he would be sitting there. If you have to teach something, you prepare and you try to understand stuff. He is not trying to judge you how well you have taught. He is trying to judge to see what your learning skills are and whether you can do that. He would give homeworks, completely optional. If you do it, good. He had exams, not optional, but if you don't do well in it, he's not bothered. He'll say, fine. So, of course, I was taking the course. I didn't need the credits for the course. So, at the end of it, I didn't do any of the homeworks. I didn't even do the exam. So, at the end of the course, I went to my advisor, my own advisor, and I said, I'm dropping this course. He said, fine. That's fine. You don't need the credits. And I filled out a form and dropped the course. It went to Gilbert Strang's desk. He looked at it. He called me. He said, I notice you have dropped the course. Why? I said, it's not fair. I've not done any of the, exams. I didn't do the homeworks. He said, are you the teacher who's judging, or am I supposed to judge this? He was actually going to give me an A. How did he judge whether I had learned from it? From the way I had structured the stuff when I was teaching it to, I was teaching trusses. Because I was familiar with trusses, you can do truss design using linear algebra, because, it's another way of using linear algebra, just like you can do electronic circuits using linear algebra. And from the fact, his own interaction with me, when he came and sat with me and he saw how I was using what I had learned in my robotics stuff, he knew. And he was planning to give me an A. And he said, you can cancel this. You can just cancel it and I'll give you the A. And I said, no, I've already had it signed by my advisor. I don't want to go tell my advisor that I'm reversing it. I told him I don't need the credit. So he said, fine. You learned what you need to learn. Done. And same thing at Berkeley. I had taken a project. I tried something very challenging. I started with a very, very challenging thing. The prof told me at the beginning, I think you are taking it on too much. You won't be able to do it. I said, I'll try it. I finally gave up. I did something much simpler. I tried to do something much simpler. Even that I couldn't manage. So I finally gave up on the day it was to be submitted. I went to him and I submitted it. And I said, I couldn't get past this. This is what I managed to do. He looked at me and he said, I'll give you another 2 days. Go do it. He was not interested in giving me a bad score. His idea was that I will learn something more. He said, I'll give you 2 more days. You go do it. right? So they, especially in graduate schools, the real good places, they don't look at progress based on, what your scores are in exams. As I said, no, a lot of them said, you IIT kids from India score very well in exams. We give you a problem where you have to make assumptions. You all, start crying about, question is bad and stuff like that, which is very true. At IIT, if we looked at a question paper and we found something missing, we would go and complain and say, oh, the question was wrong, so please give us full marks.
Wow, that was such an insightful talk, sir. This 1 hour was really informative and valuable. Thank you so much for being such an inspiration to us. We are grateful for your time. And thank you for the audience for being so active. Looking forward to more talks from you, sir.
Good luck to all of you, and hope all of you end up doing something you really want to do. Okay? Good night.
Good night. Thank you, Jaggi.
Thanks. Bye-bye.